Okay, hello everybody. Good evening, all of you guys. I hope that you are. Guys, am I audible to you? Please let me know. First of all, please let me know that I am audible to you or not. After that, we will start our class. Just confirm that am I audible to you or not. Good evening, Muhammad. Good evening, Askar. Good evening. So first of all, everybody, just listen me carefully. Please type your name on your username on the Telegram so that it's easier for me. Okay? Yeah. Good evening, Muhammad. Good evening, Senthil. So please give me the virtual attendance, guys. I'm very excited today. Because today is our first class, guys. Right? And always, first class is very, very special for me. Okay, great, guys. So, all right, everyone, let's gear up. So, guys, as you know that from today itself, we are starting the IPC, Instrumentation and Process Control, right? Guys, one of the most important and scoring subject of the GATE. Okay, this subject is not just about the formulas. It's about the understanding concepts deeply and applying them smartly. So I want full energy, guys. I want full energy from you, full focus and full commitment from each one of you. I hope that I'm audible to you guys. Give me the response. I'm saying, guys, I want full energy, full focus and full commitment from each one of you guys. Each one of you. So are you ready or not? Please tell me. Are you ready for this journey to achieving the single digit rank in the GATE? Yes or no? Are you guys ready? Are you guys with me? Yes or no? Please let me know, guys. We are not here just to complete the syllabus, guys. We are here to master it. Remember this word. Okay, great. Very good. So, guys, first of all, a very important point I want to discuss with you is that, yes, we know that hard work is very important to achieve any goal. But specifically in the competitive examination, smart strategy, smart study is very important. Right? It is clear to you or not? What I'm trying to say, guys, I want to make you understand a very simple thing is that it's nothing like that only the top 100 students are working hard. No. So for top 100 rank, minimum you can see 2000 students are working hard. Right? But what is the difference? Where is the difference? Difference is basically in the strategy, in the smart work. Kya padna hai is important. What to study is important. But what to not to study is very important, guys. So in this era of, you can say online coachings, or you can say that there are number of platforms are there. So guys, to basically मैं अगर ये दिखाना चाहूं कि what I'm doing differently, so unnecessary reading the, you can say, the theory and all that, the unnecessary things, the unnecessary stuff which is not important at all, we will not cover at all. We will not cover it all, guys. Right? What we will cover? We will cover the only that content which basically give you, you can say, the path. Here you can get the single digit rank. Right? So remember, guys, every concept we will study will be the GATE oriented, first of all. Right? And every question we solve will build your confidence. Right? It's my promise to you. Okay, I don't know that it may be possible that some new students are watching me live, right? And here some students are old, So, and they know it, okay? And every class will take you one step closer to your goal, guys, believe me. So my last words are, so stay consistent, revise regularly. It is very, very important to revise the subject, guys, and don't hesitate to ask the doubts, right? So don't hesitate to ask the doubts. You can write on your notebook on the first page this line, don't hesitate to ask the doubt, guys, because see, doubts, if your doubts, okay, if let's suppose you are studying or you are revising anything, okay, and you are facing any doubt and you are facing any difficulty, but if you will hesitate to ask that, considering, okay, it may be possible that it is a very silly doubt or it is a silly concept, you know? So please remove all this phobia from your mind, guys. Every single doubt is important for you. It may be possible that it is not important for others, right? But don't bother about others. Okay, so let's make IPC your strongest subject, guys, and crack GATE with the confidence. I hope you guys are ready. So are you ready? Yes or no? Please let me know. Please let me know with a message, are you ready or not? After that, I'll start the IPC subject, which is a very, very important, very scoring subject. Even by, you can say, after the GATE, when you will appear for the interview, or after the interview when you will join the PSU, in that also, as you know that there is a automation in the plants, so this subject will help you to understand all the processes. Okay, so once again, good evening all of you guys, and let's begin the subject. So as you know that it's lecture number 1, and we are studying the instrumentation and process control. So this subject is very, very important. Because why it is important, let's start the subject, guys. First of all, I'll break the subject. See, guys, whatever we will study, first of all, we should know that what we have to study this. Okay, one goal is very clear, that okay, I want to achieve more marks, I want to achieve full marks in a particular subject in the GATE examination, but you can achieve the full marks, and if everything is clear to you in your mind about the subject, everything is clear in terms of why we study this, what is the basically importance of this subject in the chemical engineering, right? So first we will break this subject into topics, and after that, slowly I'll tell you that how this subject will help you after getting the PSU. Okay, so first of all, I'll break this, you can say, the content of the IPC marks wise. Okay, so if I talk about the marks, so guys, IPC single subject, IPC is the subject which has the weightage 6 to 8 marks, guys, right? In the rare scenario, it can come to 10 or 11. That is a different thing, right? Some previous years has that weightage of 10 marks also. That is a different story, but on an average, you can say that 6 to 8 marks you will basically see the questions in the GATE examination, right? So if I'll break this subject, guys, so first one will be the Laplace transform. First one will be the Laplace transform, and I'll club this Laplace transform with the first order system. First order system. Okay, so as you know that Laplace transform is the mathematical, you can say the chapter of maths, but in the IPC, Laplace transform is very, very important. You can say this is the heart of the IPC. Without Laplace transform, you cannot touch even a single question of IPC, guys. Okay, so from Laplace transform and first order system, you can see 1 to 2 marks. After that, it is a second order system. Second order system, guys, if you'll face any difficulty, please let me know. Okay, second order system, and just write all these breakup, because this will help you when you will study all the content. Now this will basically help you at the last of the syllabus. Second order system, it has around 2 marks weightage. Third will be your closed loop control strategy, right? Closed loop control strategy. Don't worry what I am writing here, please don't worry about that. Okay, I know that you are guys are unaware about all these terminology, like what I'm writing, closed loop control strategy, what is it? Don't worry about that. Okay, just break these topics and just write the weightage, and slowly we'll get what I'm writing here, right? Closed loop control strategy has a weightage of 2 to 4 marks. After that, frequency response. After that, frequency response, guys. Frequency response chapter has a weightage of 2 marks. After that, advanced control strategy. Most of the plants in the PSUs uses this advanced control strategy to control their process, guys. Okay, advanced control strategy has 1 to 2 marks weightage, guys. After that, valve and its characteristics. Valves are very important in the PSUs, guys, or you can say in any plant, because through the valve we are basically control our process value, right? So valve and its characteristics has the weightage of 1 to 2 marks, right? Is it clear to you? So this is the breakup of the IPC. So we will cover each and every single word in the IPC, or you can say that single word is you can say contained in all these chapters. So again, I'm saying that don't worry about that, just follow what your faculty says, right? That's it, nothing else. We want your hard work only, that's it, nothing else. Okay, बाकी आप सब हमारे ऊपर ट्रस्ट करके छोड़ दीजिए कि हाँ सर जो करेंगे हमारे लिए अच्छा करेंगे, right? So just follow the lectures and watch live lectures if possible. Otherwise you can watch these lectures in the recorded format also, right? Okay, it is clear to you? So first of all, guys, see, we will start our IPC subject with the Laplace transform. Okay, and after that we will start the first order system. These are the breakups. We will cover each and every, you can say, word, whatever you can see here, right? Now please tell me one question. Why we have to study the IPC, guys? What is this subject for? What is the importance of the IPC in the chemical engineering curriculum? Can you tell me? Guys? As its name, you can see its name, Instrumentation and Process Control. Instrumentation and Process Control. What is it? Don't think so much. Whatever the thought you can share with me, there is no problem. Don't think that I'm saying wrong or this and that. Okay, so please tell me why there is a requirement of IPC subject, guys. And believe me, guys, that we will cover each and everything from basic level, right? We are consider that you guys basically does not know anything. You guys are at the zero level. We will start from the zero, because if the foundation is strong for us, then there is no problem to build up, you can say, the 30 floor building. To know how the instruments are working in backend in the process plants. Okay, great, very good. Because we are used to being the process engineer, we should know how an industry works. Okay, great. As a chemical engineer. Okay, great. Anybody else? Yeah, Anushka is there or not? Chetan, ready? What is your point about this? Why we have to study the IPC? how the signal transfer. Okay, great, great, very good, very good. Yeah, Anushka is there, Chetan Reddy is there, Senthil. I'm getting so much interesting, you can say, answers, and I'll explain each and every answer. Please guys, tell me. Yeah, Senthil, everybody, please. जितने भी आप मुझे देख रहे हैं, please, all of you guys, please interact with me. This will help you. Believe me. So I got two, or you can say the three interesting answers. How the instrument works in the industry. Okay, to understand the process control in real world application. To understand the process control in real world application. Okay, great. So I got some different point of view. All these are your perspective about the IPC subject, guys, right? And now I'll discuss why IPC is very important in your curriculum. After that, you can compare your answer and decide that where your answer can be fitted, guys. See, so first of all, this subject name is Instrumentation and Process Control. In some of colleges, there's a one other name of this subject that is called Process Control and Dynamics. Okay, Process Control and Dynamics, or Process Dynamics and Control. It is also called PDC. It is also called PDC. PDC, Process Dynamics and Control, right? And but common is your IPC. So actually your focus shifted towards the instrumentation part because its name has this word, instrumentation. That's why your focus is shifted towards the instrumentation wala part. To know how the instruments are working, this is not our task, first of all. Okay, let's give the thought why we have to study this, because every word which we will use in the, you can say, in this subject, that will help you, or that we will have to understand that what is the basically meaning of that word. Okay, so how the instrument is working, this is not our cup of tea. That is the, for that purpose, instrumentation people are there. They will take care of it. They will take care of it, how the instruments are working, right? It is clear to you, right? After that, Mohammed answer is, because we are used to being the process engineer, okay, we should know how an industry works. See, how an industry works is a very, you can say, I can say that it is a very umbrella term. I can add any term in the industry works. It may be in the, I can say the administrative level. I can there are, you can say there is no any specific you can say thought in your answer. Okay, so how industry works is also not our, you can say, as an engineer, it's not our task. Forget about that. How the signals transfer. Okay, so how the signals transfer, I can take this answer, because yeah, signals. Also, if I'll tell you how if your answer is how, then it also comes under the instrumentation people, guys. Because for chemical engineer, if signal will transfer from one location to another, that's it for us. That's it for us. Okay, how, why, that will also take care about the instrumentation people. To understand the process control in real world application. Yes, ready. So in real world application, we cannot say in the real world application, actually this we have to be focused in our plant only. Okay, yeah, Pranvika says that to ensure the uniform quality standards for production. Very good, Pranvika, very good. So there must be a, you can say, a huge round of applause for the Pranvika, because this line is, you can say, is very steady, and you can say that she's right. She's right, guys. She's right. Okay, so this is for the Pranvika. To ensure the uniform quality and standards for the production, what is the meaning of this? Let's take a very simple example. Let's take a very simple example. What I'm saying. Let's take a very simple example, guys. Okay. Let's suppose I have a tank. I have a tank, right? I have a tank, guys. And in this tank, hot water is there. Hot water is there. And I want that the temperature of this hot water must be 80 degrees Celsius. Let's suppose. Right? And with the help of any, you can say, cold water stream, with the help of any cold water stream, we basically are maintaining this 80 degrees Celsius temperature. Okay. So let's suppose all the operations are manual. All the operations are manual. Let's suppose this is the wall. This is the wall of this cold water stream. All the operations are manual. It means that everything is basically taken care of by the humans. Let's suppose the temperature is now 90 degrees Celsius, right? So let's suppose any worker measuring the temperature, okay, first of all, that it is not possible for human that for every second they are checking the temperature. First of all, it is actually not possible, right? It may be possible that we are checking this temperature after 1 hour. Means that before 1 hour it already reached up to the 90 degrees Celsius. So it means that our main motive is, my main motive will not solve here. Yes or no? So that's why automation is very, very important in the industry to ensure the product quality, to ensure the uniform quality, and to ensure the production. Right? It is clear to you. So these lines are very static to ensure the uniform quality and standards for the production. If I want 80 degrees Celsius temperature of this water, then this temperature should be 80 degrees Celsius, guys. There is no scope for the error. There is no scope of the error. It is clear to you. So this is the basically the thing this subject is for the automation. For the automation, different elements is basically working together to control our chemical, you can say, chemical industry process, like in which there are controllers, there are valves, right? There are valves, there are measuring instruments. So there are, you can say, where you can say there are number of elements are there, number of instrument are there, and they are working together to control, you can say, the process, to maintain the process. Okay, or in other words, I can say that irrespective change in the input. Now this is the bookish language. This is the bookish language. I can say that what is the aim of this subject? My aim for this subject is irrespective of change in input, irrespective of change in input, output must be constant. Guys, there can be change in the input. Okay, there may be a change in the input, but my output must be constant. Is it clear to you or not? That output may be anything. That output may be the quality. That output may be the temperature control. That output may be the, you can say, any chemical composition. That output may be anything. So my main aim is to control the process. So my output must be constant, irrespective of the input in the change. Am I clear with this or not? This line is clear to you or not? Please let me know, guys. Everybody, Chetan, Pranavika, Senthil, Mohammed, everybody, Anushka, everyone. I need the confirmation from each and everyone, guys. So there are number of hardware elements like the walls. Walls are very, very important function. There are controllers, right? Different processes. Okay, different are processes. Great. So, like in this slide, you can say here we will read the controllers. Here we will read the, you can say, the response. Here we will see the control strategies. Okay, here we will see the walls, how the walls are operating, how the walls will basically control the process and all that, right? And these are the process, first order, second order, third order. These are the processes basically, right? So this is the main objective of this subject. What is the main objective? To control the chemical process actually. Okay, means the aim is, irrespective of change in input, my output must be constant, guys. Great, very great. Okay, so this is the introduction of this subject. Now we will jump towards the Laplace transform. First we will read the Laplace transform, right? The required part, you can study the Laplace transform in detail in the mathematics, but for the IPC subject, whatever the important part is, I'll explain that. Okay, again I'm saying, I'm considering that you guys are from first year. Okay, you basically are not aware about anything. You are not aware about the mathematics. You are not aware about the IPC. I am considering this. Okay, and so that's why I will start with the very basic level, or you can say zero level, and I will reach, we will reach the advanced level, and we will cover up the entire syllabus with the, you can say, this strategy. Okay, guys. So first of all, please write the heading Laplace transforms. Please put the heading Laplace transform. Please put the heading Laplace transform. Now, I know that a question may arise in your mind, why we are studying the Laplace transform in the IPC? What is the need of it? What is the need of it? It is clear to you or not? So first we will try to understand the importance of the Laplace transform. Laplace transform is a very fantastic thing, guys. Very fantastic. This operation is. How? See. First of all, we have to deal with the differential equations. Okay. We have to deal with the, you can say, the integration problems. Right? It is clear to you or not? It is clear to you or not? And there are number of, you can say, there are number of difficult mathematical operations are there, and we have to deal with it. Okay, so generally for the process control, we have to deal with the differential equations. And the beauty of the Laplace transform is that the Laplace transform converts this differential equation into the algebraic equation. And guys, you know, I know that to deal with the algebraic equation is very, very easy for us. Yes or no? Please, yes or no? Tell me that it's clear to you or not. Okay, I got a one answer also, that we need IPC for pinpoint accuracy of the operating values and proper control of the system. Yes. Yeah. So Ayan Jyoti Chakrabarti. Yeah, great. This very good. So very good. So your answer is right, guys. That IPC is pinpoint accuracy. We cannot say pinpoint accuracy because we cannot achieve the pinpoint. I'm saying that I have to maintain the temperature 80 degrees Celsius. So it is not possible practically at all to achieve the 80 degrees Celsius temperature. right? That's why we'll take the, you can say, plus minus 5% error. Means that if the temperature is 81, 82, then that's okay for us, right? Yeah. So yeah, but your answer is if well, ideally it will say, then this will be your answer is correct, guys, because we have to keep a certain value for operating variables, operating values, and we don't want to change that operating values. Means that if any reaction is operating, or you can say converting into the product at the 70 degrees Celsius, then we don't want to disturb this temperature, guys. 70 degrees Celsius, yes or no? If you will disturb this 70 degrees Celsius temperature, then what will happen? We cannot get our desired product, guys. Yes or no? Okay. So yeah, great, Chakrabarti, great. So that's why we are basically studying the IPC. Okay. So what I'm saying that most of the dynamics process are modeled with the differential equations, guys, right? And so Laplace transform basically convert these into the algebraic equations, and this is, you can say, easy for us, or you can say easy to model any process with the Laplace transform. So for you, I'll write all these information. What I'm saying, first of all, what is use? Okay, use is, it is basically the simple development of, please write all these things, simple development of input output models which are very useful for control purpose. Please pay attention here. Everybody, please pay attention here. I want to clear all the doubts before it comes into your mind, guys. I'm using a word here, input and output. And most of the time, like in the CRE or in other subject also, input and output means that there is something which is coming into the system, like any flow rate. Output is my, you can say, kind of your conversion, all these things, right? That is in the CRE. Input and outputs are very specific words. In the IPC subject, input and output are not any specific words. Input can be anything, output can be anything. Input can be a signal, output can be a signal. It is clear to you or not? Right? It is clear to you. So input and output are very general terms here. Right? So yeah. So simple. It is with the help of Laplace transform. It is a simple development of input-output models which are very useful for the control purpose. Right? It means that input may vary, but my output must be constant. So for that, we have to develop the input-output models. My output can be different, guys. My output can be disturbed. Who can disturb my output? Input. What is an input? Input can be anything. Right? Input can be anything. Let's suppose my output is the temperature. I have to maintain my temperature at 80 degrees Celsius. That 80 degrees Celsius is my output. That variable, the constant value of that variable is my output, guys. So it's not mandatory that any temperature in the input can disturb this value. It may be possible that the flow rate may impact this value. So input can be anything, output can be anything, right? So for irrespective of input change, there must be output, there must be a constant output. For that model, we have to develop the relation between the input and output, and that will be done by the Laplace transform. Another, please write it, that most of the dynamics processes, are modeled with differential equation. So Laplace transform, please write all these things, okay? Laplace transform converts these into algebraic equation, right? Please write all these things and let me know that you are done with this or not. If you are done with this, let me know, guys. If you face any problem, let me know, okay, without any hesitation. If you want to ask, please ask. Doesn't matter that on which platform you are watching, just let me know through the message. Great. Now, okay, good. Now the question is that, okay, sir, we'll use the Laplace transform because it will help us to develop the input-output models, and also it converts the differential equations into the algebraic equations. Now coming to the mathematics part. Now what is this? Basically the Laplace transform. Okay, so first of all, try to understand it, guys. Let's suppose I have a function f of t. I have a function f of t, right? And t is basically greater than equal to 0, right? For t is greater than equal to 0, let's suppose my function ft is defined. Okay, we are not talking about undefined functions, we are talking about only the defined functions. I have this f of t, right? Is it clear to you or not? Okay, so if, just try to understand it, I have the two variables, one is t and one is s. One is t and one is s. Okay, I'll tell you what is this, all these things, right? Now I want to do the Laplace of f of t. I want to do the Laplace of f of the t. Then how we can do this Laplace? So actually Laplace is a integral transformation, you can say. It is an integral transformation of a function. Like this is my f of t, and if I want to calculate the transfer function, calculate the Laplace transform of this f of t, then first of all I have to multiply with e raised to power minus st, right? And I have to integrate this function. I have to integrate this function from 0 to infinity. Whatever this value we are getting, that we will say, okay, that this is the Laplace transform of f of t. So if I will calculate the Laplace transform of f of t, then this is the notation of Laplace of the f of t, and that will give us the f of s. After the Laplace transform of f of t, I am getting f of s. F of s is the value of the function after the Laplace transform of the f of t. So there are two variables, t and s, right? It is clear to you or not? Both t and s are the independent variables. Okay, I'll write here both t and s are independent variable. Right? Here T is the time domain, S is the frequency domain. T is in the time, S in the frequency. Both T and S are independent variables, guys, and S is basically variable which is defined in the complex plane, right? What is the complex plane? I hope that you guys are aware about it, that a complex number is defined as, in the general form I can write A plus iota B. So S is the basically a variable which is defined in the complex plane. T is the basically you can say stands for the time, right? So let's suppose f of t is a function. Above t is greater than or equal to 0, this function is defined, and if I want to calculate the Laplace transform of it, then I have to do this process. What is this process? First we have to multiply with the e raised to power minus st, exponential raised to power minus st, by multiplying this, and we have to integrate this all this value from 0 to infinity. After that, whatever the value I'm getting, that is that Laplace transform of the f of t, right? So now f of t function is transformed in the s function, right? The t domain function converted into the s domain function, guys. So through the Laplace transform, we basically convert our t containing function into the s containing function. In the further lectures, we will study the inverse Laplace also. In the inverse Laplace, we convert basically s function into t function. Am I clear with this or not? Please let me know. I'm not clear? Yeah, Pranvika, I'm not clear. Senthil, ready? I'm not clear, yes or no? So from t to s, we will use the Laplace transform, and from s to t, Laplace inverse. That we will cover in the coming lectures, guys. I hope that there is no problem at all. So this is only the mathematical definition of the Laplace transform. So can I calculate any Laplace transform if I have the, you can say the f of t? Yes, we can calculate it. Let's take example of it, guys. Please, this is my example number 1. Please try to calculate. Let's suppose my f of t is equal to 1, and this is defined for t is greater than or equal to 0. Find the f of s. Find it and mind it. Can you repeat the s is equal to a plus iota beta? Yes, I can repeat. So please, others, please start to solve this question. Yeah. Meanwhile, I'll clear the doubt of Mohammed. See, Mohammed, this is a complex number, a plus iota beta. Right? It is clear to you or not? So don't worry, don't you can say bother about it. What I'm saying, I have two domain, time and s, right? T and s. There is two variables are there, right, which are independent, time and frequency. So I'm saying that s is basically defined in the complex plane, a plus iota beta. That's it, nothing else. Okay, this slowly you will get how s is equal to a plus iota beta is useful for us. Okay, how in the, you can say the complex number, why in the complex number it is defined. Slowly you will get all these things. Don't worry about that. Okay. Yeah. Please calculate f of t is equal to. Okay, let me calculate this for you guys, and meanwhile just let me give your answer if anybody solved this question. It is very simple. If I want to do the Laplace of f of t, then it means that it is my integration 0 to infinity e raised to power minus st multiply by f of t. F of t value is 1, so it is my 1 into dt. Right? So what is this? Laplace of f of t is what? It is my f of s. What is it, guys? I think it is very simple. Yes or no? It means that you have to find out the integration of e raised to power minus st. Yes or no? It is my e raised to power minus st. Multiply or divide, guys? I think in the integration it is divide. Divide with minus s. Yes, yes or no? So what is the everybody is aware about it? Integration of e raised to power minus st, yes or no? And now just apply the limits. So f of s is equal to minus 1 upon s into e raised to power minus infinity minus e raised to power minus 0. E raised to power minus infinity is 0. E raised to power minus 0 is 1. So it is minus 1, minus plus. So what is my f of s, guys? My f of s is 1 by s. Yes or no? It is clear to you or not? So Laplace of 1 is nothing but it is my 1 by s. This is your answer. If you are not okay with it, tell me. Guys, the initial 4 lectures are very important. If you will miss it, you cannot grab, you can say that you cannot even solve a single question in the gate. If you will miss the 4 lectures, initial 4 lectures. Initial 4 lectures are basically to build your foundations so that you can solve any question. Guys, as you know that gate examination is conducted, framed by the IITs, and IITs are well known about the conceptual things. They will create a question conceptually, right? Revising the formulas will not help you at all. Right? I'm speaking this frankly. Okay, so if you want to crack this examination with a very good rank, then you have to study from the root level. Okay, from the root level. Okay, next question. Please calculate the next question. You have to calculate the Laplace transform of e raised to power at. Please tell me. Please tell me. Please tell me, guys. Please tell me what is your answer? What is your answer? Now I'm saying that we have to calculate the e raised to power at. Very good. Okay. Pranvika, 1 by s minus a. Okay, let's see. Let's see, Pranvika. Okay, let's start this. I think you got your answer, guys. Let me solve this problem. Now, very simple. Again, I'll start the process. Laplace of e raised to power at. So what will be the Laplace transform of this function? It is my integration 0 to infinity. First of all, this is my function and I have to multiply with this function to the e raised to power minus st into dt. I can write this as 0 to infinity e raised to power a minus s into t into dt. Yes or no, guys? I think that it is clear to you. Yes, is it clear to you or not? Okay. Or I can write this function as 0 to infinity e raised to power minus s minus a into t into dt. It is clear to you or not? What is the integration of it? What is the integration of it, guys? I hope that there is no problem in the integration. There is no problem in the integration. Clear? Okay. So I think it is my e raised to power minus s minus a divided by a minus s. A minus s. Yes, it is clear to you or not? Right, now we will put the limits. Okay, it is my 1 divided by a minus s into e raised to power minus s minus a into infinity minus e raised to power minus s minus a into 0. So it is my 0, it is my 1. So it is my minus 1. Can I write this? F of s is equal to 1 divided by s minus a. This minus and minus, this is my f of s. Yes, yeah, Pranvika, so your answer is correct, Pranvika. Your answer is correct. F of s is 1 by s minus a. So Laplace of e raised to power at is basically 1 by s minus a. Sir, if we have to do the integration each and every time, then what is the benefit of it? Yes, you are correct, guys. You are correct. If every time we have to do the integration, then what is the point of simplicity? You are correct. Okay, so don't worry about that. We will remember, we will know some, after knowing some properties of the Laplace transform, we will calculate all the transfer function without any integration. Don't worry about that. Just to make you understand what is the Laplace transform, what is the basic of the Laplace transform, or you can say what is the root of the Laplace transform. It is coming from the integration. I'll just repeat, I just follow this path. Okay, in the future we will not do the integration to calculate the Laplace transform of any f of t. Don't worry about that. Okay, don't worry about that. Is it clear to you? Okay. So this is a table, guys. This is a table. In this table, there are 12 number of formulas are there, right? And we have to remember all these, you can say, the formulas. These are very basic formulas, right? Some of formulas we will, you can say that we will calculate the transfer function of the some of the formulas, but like at the start of the lecture, we just calculate the Laplace transform of the 1. Laplace transform of the 1 is equal to 1 by s. We should know this. We should know this. Laplace transform of e raised to power at is 1 by s minus a. Right? Laplace transform of cos omega t. See, there is no need to calculate each and every formula with the help of integration. There are, you can say, 10-11 formulas which are important for us. Okay, or if I'll say that this one, this one, this one, this one, this one, these are the important formulas. These are the important formulas. We have to remember all these formulas. Okay, and also we will understand these formulas with the help of the properties. Okay, don't worry about that. So like it is my Laplace of the t is 1 by s square. Laplace of the t square is my 2 factorial s divided by s cube. So basically this formula is coming from the fourth formula. If you have the t raised to power n, then the Laplace transform of the t raised to power n is n factorial divided by s raised to power n plus 1. Very, very important. Very, very important. Okay. T raised to power n. Laplace of t raised to power n, guys, what? It is n factorial divided by s raised to power n plus 1. This formula is not that much important. We will not use at all. T raised to power a. So basically here n is my, should be integer 1, 2, 3, 4, 5. And it should not be in the fraction. A here is my, you can say, any real number. Any real number. It can be in the fraction also. So that is the formula. This we cannot use this fourth formula if your n value is fraction, because there is you can say nothing makes sense of the factorial of the fraction value, right? So t raised to power a is my gamma function a plus 1 divided by s a plus 1, where a is my any real number, a is my greater than 0, any real number. It can be 0.5 or in anything. But this we will not use in our IPC subject. This I already calculated, very important. Cos omega t, s divided by s square plus omega square. Sin omega t, omega divided by s square plus omega square. Only difference is the numerator. Cos hat, so cos omega t is my s divided by s square plus omega square. Now in the hyperbolic function, this is the same, only from instead of omega it will be a, and instead of plus it will be minus. Similarly for the sin hat. Okay, again 11 and 12 number formula I'll you can say make you understand all this formula with the help of the properties. Don't worry about that. Okay, if you are okay with it, just give me the confirmation so that we can move ahead, please guys. One thing I have to tell you, my energy is totally dependent upon you. We are not T and S, that we are independent variables. No, we are dependent variables, guys. We are dependent variables. If I can see the energy of each and every student on the, you can say, the channel on the through the comments, my energy will be higher and higher and higher, right? So my graph of energy will be from start to end like this. If I can get that vibrational energy from you. Okay, so how do we use for the gamma function for 5 subdivisions? Yeah, Pranvika, I'm saying that this is not useful for us. That is the mathematics part, right? At the start of the lecture, I told you guys that this is very important to study all these things which are very important, but the you can say the unnecessary things we will not discuss. Okay, if you want, I'll tell you in the, you can say, in your chat. So just drop me a message, right, and give me any question. I'll tell you each and everything for that. But in the IPC subject, we will not use this, so don't worry about that. Yeah, in the mathematics part, when we discuss the Laplace transform, there we will go through in detail. Don't worry about that, right? So as far as IPC concerned, there will be no use of all these you can say gamma function here for this purpose. Yeah, so now please write please put the heading theorem 1. Please put the heading theorem 1 and put the heading linearity of the Laplace transform. Linearity of the Laplace transform. Linearity of the Laplace transform. Please tell me that everything is clear to you or not. And also, once you are done with the heading, let me know so that I can explain it. Okay. Please put the heading Laplace theorem 1 is linearity of the Laplace transform. So guys, Laplace transform is a linear operation. Okay, it is a linear operation. Okay, means that I'm saying Laplace of a f of t plus b g of t. If I have to calculate the Laplace of this function, then by separately I can calculate the Laplace of the f of t, Laplace of the g of t, and I can add them, right? So this shows the linear property. So Laplace transform is a linear operation. Okay, so don't worry about that if I have to calculate the Laplace of any combined function, that what we have to do. It is, as you know, that that in the integration also I can do the integration separately for the separate functions, right? And this is also comes from the integration itself. Okay, so I think that makes sense, that yeah, Laplace transform is my what? It is my linear operation, right? It is clear to you or not? Okay, just I'm saying that let's take an example. Let's take an example. Laplace of 3t plus 12. Please tell me. Please tell me that what is the Laplace transform of Laplace of 3t plus 12? So simple. Question is very simple. It means that there is no need to worry about anything. Just do the Laplace of separate terms. Okay, it means that I can write it as 3 Laplace of t plus Laplace of 12. 3. What is the Laplace of t? It is, I think, 1 by square. Plus it is my 12, and you can say what is the, see, any constant Laplace of any constant is a by s. Okay, so it is my 12 by s. Yes, yeah, Pranamika, very good, very good. Let me take another example. Tell me now, what is the Laplace transform of a minus b t whole square? What is the Laplace transform of a minus b t whole square? Please tell me. After that, tell me what is the Laplace transform of, let's take another example also, cos pi t. Okay, cos pi t. Okay, let me solve this question, guys. Let me solve this question. I think I can write this formula. You can solve this bracket, and you can write this expression like a square plus b square t square minus 2abt, right? And you can write the Laplace of individual terms. Okay. What is it? I am saying that any constant number has a Laplace divided by s plus b square. Now this is t raised to power 2. It means it is my t raised to power n. Yes or no? It is my t raised to power n. What is the t raised to power n? It is a 2 factorial, means it is 2 divided by s raised to power n. N is my 2 plus 1. It means s to power 3. Right? Minus 2ab. And what is the t? T is 1 divided by s. So this is the Laplace transform of this problem. Correct? Correct or not? What is cos pi t? Very simple. What is cos? It is my nothing. It is my cos omega t. What is it, guys? It's nothing, but I can use the formula cos omega t. Right? Okay. Nothing. What is the formula for the cos omega t? What is the formula for the cos omega t? It is my s divided by s square plus a square. No, sir, not a square. It is omega square. Okay, great. That is my omega square. That's it. What is the omega here? Omega is my pi. Yes or no? So it is my s divided by s square plus pi square. Yeah, Pranvika has answer s divided by s square. S divided by. Okay, you are giving the answer of cos pi. S divided by s square plus pi square. Yeah, great. Okay, very good. One more example, guys. Let's suppose your f of t has cos square omega t. Tell me, what is the Laplace transform of this? What is the Laplace transform of this? So Laplace is a very simple, you can say that the concept, guys, as far as IPC is concerned. Okay. So don't worry about that. Don't worry about that. Please tell me, yeah, Pranvika, how to solve this question? I think this question requires some knowledge of the trigonometry. Okay, right? So guys, are you aware about the cos 2 theta formula? What is cos 2 theta? Cos 2 theta is nothing but it is 2 cos square theta minus 1. And it is similar like that. So 2 cos square theta is equal to 1 plus cos 2 theta. What is my cos square theta? It is my 1 plus cos 2 theta divided by 2. Yes or no? Here theta is my omega t. So I can write cos square omega t is equal to 1 divided by 2 into 1 plus cos 2 omega t. I think now the problem is simple, right? I can write the Laplace of, if I'll calculate the Laplace of 1 by 2, 1 plus cos 2 omega t. Now I can write the formulas, guys, right? What is the Laplace of the 1? It is my 1 by s. Plus, what is the Laplace of cos of 2 omega t? It is very simple. It is the formula. Just apply the formula of the cos omega t. Cos omega is s divided by s square plus omega square. Now here omega is not omega. It is 2 times omega. So it is my 4 omega square. Yeah, Pranvika, if you have any problem or anybody has any problem, please tell me. Only one student is basically interacting with me. I don't know that what others are doing here. You are, other guys are, you are busy in something else, or yeah. So and Jyoti 3 by s plus 12 by s. No, it is not minus 1 by s minus a. Okay, you are giving the answers of previous problems. Okay, just match Ayan Jyoti, please match with us. Okay, 3 by s plus 12 by s. You are giving the answer of this problem. It is not 3 by s, it is 3 by s square, because one has that Laplace transform 1 by s. Ayan, yes or no? One Laplace of 1 has a 1 by s, right? Laplace of t is 1 by s square. So it is 1 by s square plus 12 by s. Okay, it is clear to you? Yes, Ann, please do the message that it is clear to you or not. Okay. 1 by 2s. Yeah, Pranvika has answered. 1 by 2s plus s by 2 s square plus. Yeah, great. Very good. Watching. Very good. Okay, guys. Now, likewise, all these applications, you can calculate the Laplace transform of cos HAT and sin HAT through the you can say linearity property. Okay, through the linear property. So this will be your homework. So you can calculate this question at your home and we will discuss this. You know the formula for cos HAT, you know the formula for the sin HAT. So, and you have this now function. So just match your answer with the formulas. That's it. Okay. Now, please write down the theorem 2. This is my theorem 1, linearity, and this is my theorem 2, first shifting property or first shifting theorem, or in other words, S shifting. It is a very important, very it is very important. So what is this property, guys? See, let's suppose I have a function f of t. I have the function f of t. If I'll multiply this function with e raised to power at, just listen me carefully. I have the function f of t, right? And there is no need to discuss f of t is defined this and that. I already discussed that part. Okay, it is defined. That's why we are asking for this solution. Yeah. So I have the function f of t, right? And if I'll multiply e raised to power at to this function and I'll do the Laplace, then what will happen? In the S domain, there will be a change. You will say, what is the change? You will say that S, it is minus or plus with a, or it is minus or plus is depending upon this coefficient. That you can say that I can write that what is the change in the S domain? What is your action? What is your action? Action is multiplication of e raised to power at in time domain. What is the reaction? The reaction you will see in the S domain. What is that? S, and it is minus or plus, means, or you can say S, and it is opposite sign from A, right? If it is plus, then you will put here negative. If it is negative AAT, then you have to put plus. Then you have to put plus, right? So means Laplace of, if you will put e raised to power at f of t, then the Laplace, in the Laplace of f to f of t. First, what is the Laplace of the f of t? I'll write this. Just understand it. Laplace of the f of t is my f of s, and in the f of s you have to add a one change, that is in the S domain, that is the opposite. Take the opposite sign of this A, And if it is Laplace of the e raised to power minus at f of t, then Laplace of the f of t is my f of s, and just take the opposite sign like this. Now we'll just give some examples so that we can understand it completely. See, I'm saying I have the f of t. I have the f of t cos omega t. Now find out the Laplace transform of e raised to power at cos omega t. This we can solve this problem with the help of the first shifting property. Just write down the Laplace transform of the cos omega t. Laplace transform of the cos omega t is my s divided by s square plus omega square. Am I correct or wrong? Now if you multiply with this, then just make the change in the s domain, only in the s domain. So it is a minus a or please pay attention here. Please pay attention here. S square minus a. Right? This is wrong. Most of you guys commit the mistake here. Okay? Numerator is correct. Numerator is correct. S minus a. But it is not s square minus a. No. Make change in the s domain. After that, apply all the operations. So it is my s minus a. First of all, write like this, s minus a. After that, if it is a cube, put the cube. If it is a square, put the square. So this is the answer of it. So in the formula sheet, I told you guys that don't worry about that. These are the formulas which we will discuss with the help of the properties. Similarly here, sin omega t, just multiply with the e raised to power at. Do one thing, just don't touch this omega, only make change in the s domain. Even a raised to power at is also coming like this. How? See. Where is my, yeah, like my f of t is 1, right? If somebody is asking that find out the Laplace transform of e raised to power at, why there's need to go with the integration? Let's understand like this, e raised to power at, I'll just write it e raised to power at multiply by 1. What is the 1 Laplace? S. Now I multiply e raised to power at with the 1. It means just make the change in the a domain, s domain. That's the formula. Yes. Please let me know that you are clear with this or not. Please let me know. You are clear with this or not, guys. Yeah, Pranvika Mohammed. Everybody, Senthil, Askar, Chetan Reddy. Am I clear with this or not? Am I clear with this or not? Please let me know. Do not hesitate. Just let me know, guys. Just let me know that I'm clear with this or not. So there is no problem. There is no need to go with the integration method. If we know the specific properties, then we can solve the Laplace for the IPC. Don't worry about that. Okay. So guys, let me see your chat. Okay. So guys, for today's, that's it from my side. I hope you enjoyed the class. You learned the things. You learned about the IPC, and this is the introductory class, guys. Okay, I'll take 1 or 2 more lecture of the Laplace. After that, we will start our core IPC, starting from the first order system. Right? I hope you enjoyed this class. If is there any doubt, you are stuck there somewhere, please just do the message. If you want to do on the this Telegram group, then it's okay. Or you can say, if you are not okay with it, then you can personally you can drop the message on the Telegram. So guys, I hope that you enjoy the class. That's it from my side. Let's meet in the next class. Bye bye. Take care. Revision कीजिएगा. Just revise all these things. Don't stand up from your seat, guys. Okay, don't leave your seat. Just revise all the content which I am discussing, which we discussed in the lecture number 1, right? And meanwhile, after 2 or 3 minutes, you will get this PPT on the your Telegram group. Okay, and also just put your doubts, you can say, on the Telegram, right? And as you know that we will try to solve your doubts 24/7. Okay, whenever it possible, we will try to solve all your doubts. Okay, in odd timing also, that we will try that your preparation is going very smoothly. Thank you so much. Bye bye and take care. Let's meet in the next class, guys.